So it is time for us to go ahead and start our next chapter. We're going to be talking about radicals. Some of these notes might look a little bit different in your papers because of the way that we made copies. So when we're talking about radicals, that is this symbol. Up until this point, you've always been told that that is a square root symbol. And for the most part in algebra, that's really what we're using it for. So this in right here on the outside, it's called our index. So you guys are used to seeing something like the square root of 9 is 3. So what I'm looking at here, this doesn't have an index, but we're assuming that it's 2. We're doing the opposite of squaring, which squared is to the second power. But it is possible for us to have something to the cube root. And you're not going to see that on this assignment necessarily, but I can have something like a cube root. Whatever is underneath our radical is called our radicand. And we are going to be using that word quite often. So the first thing that it wants us to do is to list the first 12 perfect squares. So I could say that 1 squared is 1, 2 squared, 2 times 2 is 4, 3 squared is 9. I'm just going to keep on listing them without writing it all out. So 4 squared is 16, 5 squared is 25, 6 squared, 36. I want you to pause this video for a second and go all the way through 12 squared. I will tell you that 12 squared is 144. So this is 6 squared, this is 12 squared. I want you to pause the video and go all with all of the numbers in between that. So it starts out with our perfect square roots. Anytime I have a square root, I want to type it on my calculator just to see if it's a perfect square, because it makes my life a lot easier. So I can type in the square root of 16, that's one that we should know, is 4. 2 to the square root of 121. I can type all of these in and they'll work out perfectly, but I want to talk about what that means. So I do need to fill out my perfect squares. You can check yourself to see if you got them all. You should have. So if I look at the square root of 121, that's the same thing as 11. The square root of 121 is 11. So the math that I'm really doing here is saying 2 times the square root of 121 is 11. 2 times 11 is 22. The square root of 289 is 17. So I'm going to take 6 times 17. The square root of 400 is 20. So we're going to do 3 times 20. Pause the video real quick. Go ahead and get those answers. It's huge that when we are working with radicals that I'm taking the time typing in my calculator, because if they come out perfectly, my life is much easier. But then I have something like the square root of 32. And I get these long, ugly decimals. The square root of 180. I get these long, ugly decimals. So we're going to talk about how we can break it down to make our lives a little bit easier. And to do that, we're going to find the largest perfect square that the radical is divisible by. Now we have all the way through 12 right here, but I really think that it's more beneficial for us to go all the way through 15 because we use those often. So I'm just going to come over here and make us a little list real quick. You don't have to wait for me to get all the way through and get my hand out of the way, okay? These perfect squares are something that you should be able to spout off at any point, okay? I am going to tell you guys that at some point this week, probably towards the end of the week, I'm going to give you a pop quiz without your calculator. Can you tell me the first 15 perfect squares? 11 squared is 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. You should be able to spout these off. If you don't know these, or if you can't think for just a second in your brain and get those, I want you working on these. Probably Friday, we're gonna have a pop quiz. So not really a pop quiz, because I'm giving you heads up. I want you to be able to tell me your first 15 perfect squares. So what we're gonna do is we're going to find the largest perfect square that the radical is divisible by. So I want something that divides into 32. The easiest way to do this is to start, so 36 is a little bit bigger than 32. Start there and work your way down. Does 25 divide into 32? No, 32 divided by 25 is not perfect. Does 16 divide into 32? Yeah, it does. I know that 32 is like saying 2 times 16. Okay? I want to break that down into a perfect square and a not perfect square. Well, I know that the square root of 16 is 4. That's not going to break down. So I'm going to write my ultimate answer as 4 square root of 2. Okay, whatever my whole number is, then my imperfect square. We're going to try that a few more times, and then I'm going to turn you loose. Looking at 180, I'm going to start at a number close to 180, work my way down. For sake of a video, I'll tell you that 36 is the first one that goes evenly into 180. So I really prefer to write it like this. The square root of 36, 180 divided by 36 is 5. So 36 and 5. It's super important that we're leaving those numbers underneath the radicals. We're not getting rid of them yet. Okay? 180 is just 36 times 5. Well, I know that 36, the square root of 36 is 6. My square root of 5 doesn't break down. 6 square root of 5 is going to be our correct answer. When we get to something like number 10, the square root of 54 breaks down into the square root of 9 times the square root of 6. But because I have this 2 at the beginning, I'm just going to bring it down and multiply it. So the square root of 9 is 3. So I have 2 times 3 times the square root of 6. 2 times 3 is 6. Square root of 6. Something that is huge here, and we will talk more in depth why later, but for now I want you to go ahead and put it. Let me see where we have the most amount of room. Let's flip over to the back to the homework, and we're going to write ourselves a little note. Your answer should never have the square root of 8. We will talk more tomorrow about why we never leave an answer with the square root of 8, but I want to give you a heads up, because now that we are working on homework, I want you to know if you see square root of 8, it's wrong. Something's not done correctly yet. Okay? So I want you to do 7, 8, 9. Check yourself on the iPad. And then we're going to start on this homework page. Let's get busy.